more a journey than a talk. We are going to try to focus on that. Let me, before that, introduce Esther. Esther is one of my colleagues in Autentia. We have been working in projects not directly together, but related somehow. We have also
let me introduce you, David. Also working in Autentia for quite more time than me. And we are both Java lovers. We actually started our own Java study group in the company, I mean. And we have been studying and reviewing some Java 8 issues with all our colleagues.
Well, the journey that we propose to you today is not only a talk about the characteristics of the lambdas, but it's more a journey based on the training that we do, the consultancy, the software projects in which we are involved, and also the way that we introduce in that Java study group internal that we have at Autentia, how we introduce the lambdas and all the features that Java 8 comes with to new developers. So consider you can approach this journey in two different flavors with two different motivations. If you already know about lambdas, just take our advice based on our experience, just to know which are the dangers and which are the journey that new people is going to do approaching the lambdas. So let's start our journey. Yeah. Well, the thing is that when we start our journey to the world of lambdas, the most easier way to introduce lambdas to a new developer is by doing the relationship against the anonymous inner classes or the inner classes.
Yeah, so when you just start with lambdas, there are these promises that you can actually see here, right? And one is just think, okay, this is more like an inner class, but I can write more concise code. I can actually parameterize the behavior of our programs. We can sort of become functional programmers in Java, and of course it's cool. So that's why we start our journey with these promises in our hand. And the first thing we do when we start the journey, we need to have some things in mind so we can go through the path correctly. And the first thing that we have in mind is this correlation between an anonymous class and a lambda. And you think, yeah, it's similar somehow. You can use them in similar situations, but they are not the same, as we will see later.
Yeah, the thing is that the relationship with an anonymous inner class is a good starting point because it's an easy way to introduce to a new developer to the lambdas, because it's related to something that is used to the anonymous inner class. But be careful, because it's not the same. We will see that later. So this is an example of a real conversation a long time ago when I was first looking for introducing lambdas and how lambdas will enable Java developers to do the things in a different manner. We were looking for a use case in which we could use lambdas. And we came up with a link which was recommending some usage to introduce lambdas in a logging framework.
Of course, if you are thinking as lambdas as just in anonymous inner classes, you may think, okay, so you are actually going to create an object instance for each log statement. That really looks like an overkill.
So this is where the relationship starts to break. So the starting point is a good idea to introduce, but is that. Let's demonstrate that. The first thing that we need to remove after presenting the lambdas as a relation or something like the new way to write anonymous inner classes is to specify that they are not sugar syntax over inner classes. So if here we have an example of an anonymous inner class, which is basically invoking an execute action, which is printing something. If we take a look at the bytecode that this generates, we will be able to demonstrate the difference on that. So an anonymous inner class compiles to a different class, a different artifact, But the bytecode executing that anonymous inner class basically is, first of all, if I can see, is loading a different class. It's invoking the static initializer, the class static initializer, and then it's invoking the actual method inside the inner class.
However, if we replace that inner class with a lambda, like we are doing here, we will see that the bytecode is a bit different. There is no any additional class. We just have the main class and its initialization. We don't have any additional object created. The only thing we have is a dynamically invocation of our lambda, like any other entry in the symbols table.
Yeah, the thing is, if you take a look here, the bytecode method is creating an invoke dynamic over a symbol, a reference to a symbol, which is basically the definition of the lambda in the internal symbol table from the class. So for what it's worth, that means that a lambda is not an external artifact. It's not an external class. It's defined as a regular method on the same class. So there's the first thing that we need to clarify to the developers. So the first rule, it's okay to introduce lambdas as something like similar to the anonymous inner classes, but just from the very beginning, specify that they are not the same thing, because
yeah, we have another example here. If we just look at the file system, we will see that when compiling our program, there is no additional class created for our lambda, but it is a new class created for the anonymous inner class. That has a less impact in, of course, in our class loader. There are less objects to load. That means less memory to maintain, and of course, less garbage to collect at the end.
Yeah, another concept that is in fact not so new is the concept of functional interfaces, which are what lambdas are based on. Every one of us has ever used a runnable to provide something to be executed inside a thread. So we are pretty well used to the runnables and to create anonymous inner cluster for the runnables. Well, the runnable is an interface which is having only a method, only an abstract method. This seems like a brand new thing, but in fact, it's not such new, because after that, previous to Java 8, we were having the name of single abstract method of some types. If you look for the documentation or internal mailing list, you will be referring, you could see people referring to some types. Some types are basically functional interface. The only thing is that in Java 8, we have a brand new annotation which specifies that this is actually a single abstract method. The implications of that is that the compiler is going to do some additional checks, but at the same, it's the same concept that we already had with the sum types. And the lambdas are based on implementing functional interfaces. Functional interfaces or interfaces which defines only and just one abstract method.
And another change that we have to take into account is a change on our style. So when lambdas, we are introducing a change from the declarative code to an imperative one. Here we have an example of what a declarative code is. So we want to filter from a list of numbers those that are even. Here, we are focusing on the how to do it. We are specifying each step. How we want to iterate over the elements, how we want to store them. In the meantime, what an imperative code looks like is just focus on what you want to do, but don't specify how you want to do it. Leave it to the framework, because it's going to use some implementation that is probably optimized, and this could even be executed as a concurrent program. So I don't need to worry about that. I just tell the program, okay, I want to filter and I want to collect them as a list. Just do it wherever you want to do it.
A couple of years ago, this is an important change, because a couple of years ago I was delivering a training on Java, on advanced Java topics, it was, in fact, before Java 8 was actually released. And some of the students asked me to illustrate some real code that in which we could see the benefits of imperative code. So we came with an example, which basically means that we could have a log of phone calls, and that phone calls, we could have a stream and concatenate different operations. So in this case, the final code that we are reading is more focused on not how I should iterate, but on what I want to do. And I can concatenate the different operations that are going to be applied to my set of data. And the funny thing about that is that in this course, one of the students, and this is an important sentence that you can use in order to introduce the benefits of using lambdas and the imperative way of coding, is that the student told me, okay, this seems cool, because starting from Java 8, the only thing that I need to know to learn how to program is I need to learn English. Because it seems like more or less more natural way of reading what is being done.
And you actually could improve this a little. You can have this filtering condition, encapsulate it in a method, put it some cool name. So this could be really descriptive.
Well, another important thing is, if we again go against the problems that sometimes in the mind of the developers that are still stuck into the relationship between the lambdas and the anonymous inner classes, is the problem of the context. The context in which a lambda is executed is not the same than the context in which an anonymous inner class is executed. For example, if we try to access to the reference to this in anonymous inner class, like in this case, basically the who am I, this who am I method is referring to an internal method already defined in the anonymous inner class. So this is actually pointing to the internal artifact, the extra artifact, the extra class that the anonymous inner class is creating.
So if you just run this code, you're going to get the identifier of the inner class. However, if we change this with a lambda, well, we had to change this a little because, of course, you cannot use this within a static method in the main. So we just move it outside. And in here, this who am I is referencing to the method of the class, of the main class, not the lambda. That means when we execute this code, we can see that we are in the context of the main class. We are not in a different separated context. And that's really important.
Just remember when we saw the bytecode that the lambda is creating, just remember that the lambda lives in the same artifact, in the same class. In fact, the lambda is defined as an additional symbol on the internal symbol table. So any kind of reference is not on the only artifact that we have, which is the class defining the lambda. And well, referring with the context, we could also have two types of lambda, two classifications of lambdas. Basically, if you remember, again, if you come from the anonymous inner class concept, you could access values that are defined on the outer class, as long as they are defined as final, so they are not going to change. Well, the lambda also can access to variables and fields defined on the context in which it's declared. But if they are not, if a lambda is self-contained and is not accessing any external value, we call these stateless lambdas because are self-contained and not pointing to any other external reference. But it could happen that we could be accessing some value which is defined outside the lambda. But in this case, we say that this is a capturing lambda because it's capturing the context in which it's defined. So I have some kind of access to that. The only difference that the lambdas introduce is that this array is not necessarily, it has not necessarily to be defined as final, as long as it is not modified. So we call this effectively final. This is also a new concept introduced in Java 8. So the thing is that if we are capturing lambdas, we need to be sure that the values that we are accessing in the context in which the lambda is defined is not going to be modified.
This could be really dangerous because imagine that you are running this in a concurrent way. So you must take into account that if this outer value changes, you are going to have a conflict, and it's probably that you are going to encounter a race condition. So yeah, we already have some elements. So we want to start our trip, start our journey, and we are going to start using lambdas. The first thing that we usually do is just to stop using inner classes and replace them slowly by lambdas.
Well, the thing is, seems like a natural, when you're introducing people to do that, the first use case is mainly, okay, review your code base, and look for any anonymous inner class. If the anonymous inner class is just defining only one method, just try to replace that with a lambda. To do that, in order to do that, the only thing that you need to do is to keep in mind which is the signature of the abstract method that this anonymous inner class is doing, and replace with an equivalent lambda definition. But the only thing that you need to push attention into is take a look, because it's not exactly the same. If you, inside the anonymous inner class, are referring to this or super or any other external reference, take into account that this could be, in fact, be changing to different concepts.
And after a while, you have been replacing these inner classes with the lambdas. You feel comfortable, and then you realize, so if lambda is just an implementation of a functional interface, why don't I just define my own functional interfaces? Well, the thing is that Java 8 comes with a great package of functional interfaces, and there is a lot. So you should take a look first.
Well, the thing, this is actually important, because not long time ago, I was helping a team, an architecture team, which was upgrading the framework that they were creating in order to update to Java 8. It was not so long time ago, but they were upgrading into Java 8. And one of the developers came to me and, okay, it's exciting for them, because think in a big company, which is not very used to the latest changes, and which has different developers which are used, maybe they are using Java 5 or Java 6. This is a real case. And soon they enter a project in which they are going to upgrade to Java 8. So that's exciting for them, because there is a brand new set of new things, one of the functional interfaces, and he came to me saying, oh, look, I'm creating new functional interfaces. I already have this class, and I'm creating a functional interface on this. And I say, why do you need that? Just don't define functional interfaces just because they are. First, take a look at the complete set of functions, because most probably, you are going to find the functions that you need here. In this case, for example, imagine that you have you are using repositories that they are using JDBC connections. So you have, at some point, you have a row set, you have a row set, and you are mapping the different rows in that row set into a class from your model. So in this case, you could be tempted to create a new class, which is a contact mapper, or contact JDBC mapper, or something like that, and declare that class as a functional interface. But you are not needing that, because you already have a function which is going to translate from one space, in this case from the row set, into the contact. So the first approach is just review the set of functions that are already defined in Java 8, and try to create the lambda for that.
And the first approach usually is not the prettiest one. Here we see that this is not a clean lambda. It has a lot of things inside. So our advice is just start from the first version. Doesn't have to be pretty. Just get what you want to do. And then start cleaning, just refactor. For example, here we can just put all the creation and initialization of our contact in their own constructor. And once we have this is more clear. And we can even go and use this double dot notation. So it's going to get very clear. This is just a lambda. We are reusing an existing functional interface. We don't need to reinvent the wheel.
Well, the point here is that it could be a lot of ways of writing a right lambda. But don't try to approach or don't try to push the people entering the lambda world into creating the best or the most nice possible lambda from the very beginning. Just start with the most closer code from what it was having. And after that, refactor, clean, and improve. But that way, people is going to get less frustrated about understanding the new syntax, and is going to enter and become more comfortable on that. Well, another good thing is, after a while, we have been traducing anonymous inner classes into lambdas. We have also started to define our own lambdas. And the next point is to introduce the idea is that we could also use functions as method parameters. So this is what we call parameterized behavior.
This is actually the example from this real conversation that we were talking at the beginning. So let's see how can we use the lambdas for login. It's like a pretty straightforward case.
Well, the thing here is that on a regular case, on a regular API, this serves as an example for the lambda for a logging framework, but in fact the idea could serve for any other API or library or framework that you are deciding. Just if you keep in mind that you could provide a method in which you could get a function, you could avoid the problem that we have here. The problem that we have here is that the method evaluation, the argument construction should be evaluated before, in fact, invoking the method. Even though maybe we are not going to use that value. In this case, if the login logger is not right configured, in this case, I'm evaluating this expensive string conversion to build a message, even though I'm not going to use that.
But if we replace this with a lambda, what we have here is a lazy evaluation. So this lambda is not going to be resolved unless it's necessary. That avoids to create unnecessary objects that we are going to throw. It is less expensive and it consumes less memory.
The thing is that it could serve because it's a tiny modification from the previous slide, because we are just defining a lambda here. We're providing a lambda that could be executed or not, and seems like it's a small change, but it has a pretty big impact in performance, depending on how much time this is going to consume. For example, we have done some tests with just replace this method by a system current time millis call, for example, and this is the actual difference. Over some iterations, the difference could be quite heavy. So as much as possible, try to define not arguments, but suppliers or functions with method parameters if you don't know if you are going to use that value inside the method.
Yeah, just embrace laziness, because we all are very lazy, and it's a good thing. Another thing that comes with lambdas, composition. When you start saying, okay, this is a functional interface, I only have one method, if you take a closer look, you will see there are some default methods, like the compose and then. These allow us to compose functions before and after each other. And a cool thing that allow us is, for example, to re-implement some known patterns, like a decorator in this case. So here we want to apply different behaviors over our object, and we can just put them, declare them, and just at the end, we are going to apply all the behaviors in order.
So in this case, a decorator some kind of decorator pattern is easily implemented as function composition using those methods. But the final point using lambdas and using functions is basically by realizing that I can not only apply laziness to the evaluation of the method arguments, the method parameters, but also I could promote laziness by returning functions instead of the value. And you could say, okay, I don't see the case here because if I'm actually invoking a method, it's supposed that at some point I would like to get the value. But what this enables, if you return a function instead of the value, what it enables that is that the client which is invoking you could decide whether he wants to use directly the value, or maybe he can concatenate that value to another method invocation, or compose with another function. So you start to enable more power from your AP design.
And of course, we again avoid to create unnecessary objects, because maybe we are not going to reclaim the value of this lambda in our program because of some condition. So just let's not put the effort, let's not spend the time, and return the function.
So we are at some point in which we start to feel the power of functions, on how we compose functions. We start to feel, when we say we, is what we see in the developers following this path, this journey, we start to feel like, hey, this is cool because I have power, I'm becoming more like functional programmer in Java, which is possible, and this, you feel the great power, but with great power you have great responsibility.
Yeah, we all know that, right? So what is the danger of that? You could get hurt.
Oh.
So if you start being clever and you start doing inliners all the way, and at some point this can backfire you or another colleague. So just don't go wild. and now we are going to take a look at some cases, and let's see if they were abused or not when using the lambdas.
Well, the thing is that we have, from this point, we want to present you some cases which should be evaluated to know, in order to know if we are abusing lambdas, if we are writing more concise code. Remember that one of the promises from the lambdas is you will be able to write more imperative and focusing and concise code. So if you are not promoting readability, maybe you are not using the right in the right way the lambdas. So lambdas are not there to demonstrate how clever you are as programmer. So, well, the first thing, and these are more or less real use cases that we have found on different projects. The first thing is that, okay, you have traveled that trip, and you are composing functions, you are well used to lambdas, and at some point you know that you can use values from the context, defining the context, and at some point you realize that you want to create or use an external content. But that value is going to be changed. So if it's not effectively final, you could not be able to use that inside the lambda. But there's an easy workaround for that. Because as long as I don't change the reference, I could change the value. For example, there's a trick, which means, okay, I'm not going to have a calculated value, an int, but an array of ints. So I'm creating some kind of wrapper. I'm not changing the reference, but I'm changing the value. Please don't do this. Because at some point you lose your mind and you want to overcome this obstacle, but this obstacle of the effectively final is put there for a reason. The reason is lambdas promote parallelization and concurrent code. So if you start doing these kind of things, maybe you are going to face race condition, and maybe you are going to give a shot on your feet.
Yeah. So another example that we encounter. We were defining our own framework for dependency injection because why not? And then we were declaring this exception when something happened to a list of candidates. And okay, let's just print the candidate names. So when the exception is thrown, you get this. This is not very useful. So you know that something happened there, but you don't know which elements we were playing with. So we thought, okay, let's try to make this better, more useful for us. And let's use lambdas, of course. So you get the candidate names, you make a string, you collect them, and then you use this finisher that is the joining finisher, which is implemented using lambdas. What it's going to do, this is going to concatenate all the candidate names. So when we print it, we are going to have something like this. So this is like more clear, this is useful, we think, cool. But what happened with performance? In the first case, we get a more simple code. It is more maintainable, it is pretty, but it is much expensive than the classic, old, ugly way of, the declarative way of doing it, which is has a greater performance.
Well, the point here is that it's not necessarily a bad thing to use the stream and the collect, but because in this case we are basically using that on a runtime exception, creating an exception which should not be the regular case. So maybe the performance is, in this case, is not a big deal. So in this case, the trade-off between readability and maintainability and performance is well paid by adding that extra performance penalty. But don't use that as a regular way to concatenate an array, a short array of values, because this is something that comes up from time to time when we start developing, that people start using this pretty neat piece of code to concatenate some strings, and at the end, if you are doing that and you are focusing on the performance, maybe this is not the best solution. So always try to be consequent and try to think in which cases you are using what, and the trade-off between simplicity and performance.
Another example, when we start using optionals, we tend to use them for everything. Here we have just an event types that some of them have consumers register, but they may have not. So you need to check that before you start using the consumer, and instead of doing a plain if, you open an optional of nullable, and then you get it, and then you have to specify the else, and if it is not there, then I'm going to throw an exception. Well, I'm not sure if this is more clear and more simple than just the all if.
Again, this is another case in which we are tempted to use optional just because they are there. They are fancy, they are new. And the rule is, I don't know if this is the best, but at least compare the different approach and wrap up with your team and try to call a colleague and see, what do you think about this code? What this code does? Is clear for you? Is more clear than this one? And choose the best option always. Don't use a new thing just because there is it. Well, here there's another use case. This is from not so long time ago, in which basically a developer who were starting to use lambdas found out this piece of code, which was basically parsing a piece of XML file or XML content, and looking for a result tag and getting the value and returning the value. The thing is that when you start to get used to read more concise code, this kind of code try to hurt your eyes. So this guy came to me saying, this is a particular nice piece of code in which I think we could use lambdas to improve the maintainability and readability. And I said, okay, let's go for it. And we came with, we started by trying to get rid of the internal if, because there are so many else returns, and it's not so clear what the method is returning, and in which cases. So we came with this solution, which is by replacing the internal if and using optionals and using lambdas, this could be like a more readable. Seems to me like more readable than the previous one. It's more clear. The thing is that we could even were able, this is another case in which we started with an implementation of the lambda as it was on the previous example, and then we refactor it to simplify a little bit more.
But this actually looks good, right? I mean, it is more simple, you can understand it. You just stop here, right?
The thing is that we did not. Because once you have simplified that, the developer came to me and said, well, I wonder if we could get rid of the external check. And we were able to do that. We came with this piece of code, which at some point is going wild. It's turning the code in the opposite direction. But even better, we could convert this into a one-liner by adding the object mapper into the return sentence.
Yeah,
so
but I'm not going to maintain that. I mean, no
the
way.
point is that this is what we did. We call another colleague. It seems to me like this is not maintainable. And we call, Esther, what do you think about that? And
I say
says,
no way.
I don't understand what this is doing. So at some point, we stepped back and came back to the previous solution. Maybe we could have another solution. Maybe we could have tried to simplify the lambdas. But at some point, it's very important, above all, if the team is introducing to lambdas, that the whole team feels comfortable with the code you are writing.
Yeah, and as you keep playing with lambdas, it's easy. You are going to start playing with different functional programming concepts. And we have another one here. So for example, we have just an addition, and we have this by function that takes two input parameters and then returns the sum of both. And at some point, we need to implement different incrementers. By 1, by 2, by 3, and we are going to instantiate this increment. And since you are, all imperative, and you say, I can abstract this. I can make something more general, more reusable, so I don't have to do it each time for each case.
Well, this was funny because this code comes actually from a workshop. When the people starting to use lambdas were comfortable with functions, and we started to play around with some functional programming concepts. And in functional programming concepts, this concrete solution of trying to reuse a function, trying to fix one of the parameters is called curryifying a function. In this case, what we are doing by taking this, simplifying this, and mapping this with the original one is we are going to try to fix the second parameter. In this case, we are going to create a curryifying function which is going to return to get an integer, which is the x, and it's going to return a function. So remember that we already realized that we were able to return functions from methods, and a lambda is not anything else that a function, implementation of a method. So as long as a method can return a function, a lambda can return a function. So in this case, what we are doing here is just defining our increment by our curryifying function by fixing the value and returning a function who is capturing the reference to the second parameter. So in this case, we could rewrite the incrementers by using the increment by function and fixing which is the second value that we are going to fix in this case. It was funny because during this workshop, you tend to look for the next step, and at some point, one of the people attending the workshop tried to redefine the sum based on the clarifying function. And it came with something like this. He is defining the sum by abstracting the clarifying function, which is, okay, you have created a new clarifying function to fix one of the values, and you now go the opposite way by abstracting the value you have fixed. So at the end, you come up with a more complicated defining function based on the same function, same summing function that you have at the very beginning. So this seems like a game. This isn't like a corner case, but this is illustrative because once you start playing with functions, composing functions, and doing some functional programming, playing with some functional programming concepts, the thing is that maybe you are at some point going to go wild and overcomplicate the thing. So always try to validate with your colleagues what you are doing and if it makes sense.
What we could do here, if we just realize, is that at the top, we are fixing the input for a function, then we are applying, and then we are applying our new input. So we are resolving the function, the last function, just to create a new one. Well, we just can simplify this, remove the last apply, and this is going to return the function that we want to, right?
So with all this trouble, we have started from the anonymous inner function, anonymous inner classes converted to lambdas, and we have guided a lot of developers into the point in which they can start playing with functional concepts in Java. This is our experience, and I think that this is a good one to, because we see this over and over the same thing with different things that we are helping to move into Java 8.
As final conclusions, we could just take in mind this trade-off between simplicity and performance. Don't try to go just for lambdas because they are cool, because they seem simpler, because not always is the case. And take into account each independent case, if the performance is or not an issue, etc.
Yeah, another point is don't try to overuse lambdas, or at least don't try to create very smart code, because that code is not going to be readable. There is some kind of misunderstanding at the very beginning saying that lambdas will allow you to write shorter code. And in fact, they allow you to write shorter code, but the main goal is not there. The main goal is on conciseness, writing shorter code but readable code. So the final advice is...
Yeah, it's always to ask a colleague, do you understand what I just did? Do you think you could understand that 2, 3, 4 months from now? Because it's also usual, right? You just write it, you have been working on that for the last half hour, and you just feel so cool. But then 2 months later, you don't remember why you were doing that, and this is going to be really painful. So if you are ready to take this path, if you think that, yeah, I'm all into this journey to the wall of lambdas, we can give you one final but really important advice.
So if you have done that, and if you are willing to do that, or some other colleagues that you know are willing to do that, my best advice is not take the road to wall of lambdas. I will have another better advice. Instead of wall of lambdas, just take the road to Lambda World. This is the final commercial advice. Well, Lambda World is a conference that we are from Madrid, Jack, and from some other communities are helping to organize in South Cádiz, in South Spain, in Cádiz, the end of October. It's a very nice time to go there with the weather, with the beaches, and the thing is that Lambda World is not a functional programming conference in the sense of it's not a Scala conference, it's not a Haskell conference, it's not a, because sometimes this kind of conference for people who have taken this first road from Java to functional programming maybe is afraid of introducing into Haskell.
What looks like a like a very imperative conference, right? We are
Exactly.
focusing on the how, what to achieve, and the what we want to achieve, and not the how language, how we can do it.
Exactly. So Lambda War is a cross-language conference. Is about how you could implement or take the features of functional programming in no matter what with programming language you are working with. So, for example, we have speakers speaking from JavaScript, from Java, from C#, from, of course, Scala, Haskell, Kotlin, and just take a look, and my recommendation is just to go there. You don't need to be a functional programmer expert to go there. Finally, so that's all.
Yeah, if we have any questions, we are happy to answer them. Otherwise, we will be here the whole day. So that's all. Thank you.
We have one question there.
Okay, so the question is, how do you fight these Lambda abuse in your organization? Well, apart from calling another developer to check to see if it makes sense, I don't know, maybe some tools, I don't know, static code checkers, linters that you use or aware of, kind of to bring it more under, I don't know.
Well, the
control.
thing is that I think that the most successful way is just implementing, for example, pull request, merge request, because from our experience, you could implement some kind of check style rules or Sonar, adding some rules to Sonar or whatever, but at the end, from the point of view of mentoring someone into using lambdas, this is not going to be the right way, because you push some code, you think you have been smarter than anyone, you are proud of your code, your lambda. The lambda go there, some rule breaks and comes with a mail, you should check the quality of your, but it's not fomenting the peer review. So for example, we try to focus on peer review. One of the things that you could automate is by doing merge requests in order to, for example, to define that every pull request should be approved by 2 different persons in order to validate the lambdas. The key concept is peer review and share, because it's the way that maybe if there is someone who is more versed on lambdas usage, could serve to identify some patterns and some misunderstanding that the rest of the team is having. So it's for us, it's mandatory. It's the best case. Just try to enforce that peer review. Any other? Okay, so thank you all for coming.
Thank you very much.